Okay, this is the last broadcast of the semester. Guess we're going to be a small group today, but welcome to you if you're here for the last broadcast of the semester. I'm going to say a couple of things up front before we do any work. For people watching the video later, um, so the final assignment, I'm calling the final lab, um, you turn in. This is a way of trying to introduce you to the basics of C++, because for some of you at least you're going to go on to do another programming class, and there's a very good chance that your next one will be in C++, so we're kind of boot camping C++ this week by doing two labs from a prior semester plus one extra that I did. So you have two labs to turn in. The dates and the titles here uh, will just sort of help you figure out which one it was, but I did the first one actually back on May 14th, so you can look for class videos from that date. There's one of these labs. I did another one on May 21st, which is where I actually implemented a vending machine, much like we had for our Project 3 in C++. So you can find the video for that on May 21st. I did a lab that featured a student component, which you can find video for on May 26th. That was this Tuesday, and then yesterday, Wednesday, May 27th, I did a calculator program. And then today I'm probably going to do FizzBuzz, but since there's not very many of us, I'm happy to entertain your requests or your ideas. But anyway, if you're watching the video later, you have to turn in to get the full points for the final lab. It's 150 points for each of two parts for a total of 300 points. You can pick any two of these five. Pick and implement any two of these five. The dates are there so that you can go find the videos to review the work that we did when I did the walkthrough of these labs. So I'll put these up at the end again, just to leave those there for you to refer to. This is otherwise my last broadcast of the spring 2020 semester, so good question. So no, I'm not doing any extra credit for any extra ones, but if you send extra ones, I will review them at least and let you know how they look if you want me to. So one student has turned in a few extras, and I have reviewed those and let them know that they were okay. But I don't do any extra points for those. But that's a good question. Thanks. Someone was likely to have that question when they're watching the video later. So you turn in any two, and at the end of this walkthrough today, I will get it in the video to remind you how to submit these labs. There's three ways to do it, I guess. Three? Yeah, there's three ways to do it. Okay, so that's that before I go on. So I'll tell you what I want to do, and then if you saw something else that you want to do, we can look at that instead. So let me show my browser. Turn off Atom. Okay, so I need to switch over to... So here's our schedule. So whatever it is that you do, the two parts that you submit need to be submitted by the end of the day on Friday. That's tomorrow, May 29th. That's when the semester ends. So I don't accept work after the end of the semester. All right, so the final lab, and I've done this in I think all the videos that we've talked about it. The way I'm going to do it is with option 3, which is using REPL.it, which is an online environment for doing C++ programming and other languages. I've done that. I've gone through that already on multiple occasions now, so you'll find some of the setup stuff for that in other videos, but I will just show you how I get into it today. And then complete 2 or more of the programming challenges. So the ones that I've done walkthroughs for were listed at the beginning of the broadcast. You can do others of these programming challenges if you want for credit. That's totally up to you. But the ones where I do a walkthrough so you know for sure you got it right, those are those 5 dates, including this is the 5th one today. So this programming challenge 1, that's the bouncing ball. That's the one that's titled Bouncing Ball, so I did a video on that for that on May 14th. Programming Challenge 2, that one is the student one. So I did that on May 26th, I think. Programming Challenge 3, that's the calculator, so I did that on May 27th. And then I was going to do Programming Challenge 4, but that one looked less fun to me than Programming Challenge 5. Programming Challenge 4 has got some greater stuff where it like tells you if you got an A, it computes your average, computes GPA. I didn't find that to be all that exciting looking, so Programming Challenge 5 has FizzBuzz and a couple of other functions, so I thought that one would just be slightly more entertaining to work on, so that's the one I want to do. But I'm open to your ideas if you would like to see a different one. But if you sort of don't have any preference one way or the other, then we can do the FizzBuzz one, and then I'm happy to answer your questions. Okay, that page says stay live. Yes. So the question is this page with C++ exercises on it. Let me go back. So the link from our final lab takes you actually to the schedule from my fall 2017 offering of Programming Algorithms 1, which I did in C++. So yes, that class is still up there. And then I'll also show you just, I don't want to make this too overwhelming, but if you go to the main foobt.net page, you can actually cycle around prior semesters. CSCI 21, that's always taught in C++ at Butte, so if you go to any of the CSCI 21s and go to the schedule, you can also find additional exercises. And some of these you're going to find fairly straightforward. So yeah, so the question is that fall 2017 going to remain live through the summer? And the answer is yes, it will. They go back to the fall of 2015 right now, I think. Yeah, so I have content going back to the fall of 2015, and you're free to. One of the reasons I have these up here is so that people can go sort of use the problems for practice problems. So yes, that will be up there. There's spring of 17. So here's the fall of 2017, and there's that class which was taught in C++. Okay, now I have to go. Oh no, I don't. I will just go back to this semester and then grab the schedule. Okay, good. So everyone's cool with the FizzBuzz problem, so we'll do that one, which is the one that just I thought sounded the most appealing. Challenges, that is Programming Challenge 5 from the fall of 2017. Okay, so hopefully everyone's got Replit going. And if you haven't seen any of these videos yet, most of you who are here have seen me go through this before. But what I've started to do is carefully name my REPLs. And if you're new to the videos and you haven't done any of these yet, you create a separate REPL for each lab that you do. So every time you do a new lab, you do a new REPL. Accounts on here are free. So I'm going to make a new REPL. I'm going to do it in C++, and then the name I'm going to use is bootcamp 5_FizzBuzz. You can name yours whatever you want. I just thought that might help me remember what this one was. So this is example or walkthrough number 5 for our C++ bootcamp, which is what I've been calling this last week of work. And this one is the one that contains the FizzBuzz problem. Okay, so that's what and I don't touch anything else. Okay, and again, sorry for you guys who have seen a bunch of these that I keep repeating the same stuff, but I'm doing my best for people who the first time they might see the video they're not completely lost. So if you haven't watched these before, you can kind of move your mouse around and just explore some things. But the big ones are over here on the left here, there's this icon that says Files. If you click it, it toggles this little listing of files. And right now, there's only one file in my REPL, in my project. This middle one is version control. We're not using that, but I click on it just to point out to you that it's safe to click on it. And then I can click back on files. Settings. This is how you do, you can change the theme from light to dark. I like the light theme. You can also change the layout between side by side, where the terminal's on the side, or stacked, where the terminal's on the bottom. I like stacked for some reason. It just looks nicer to me. And then there's some other settings that you can change. Once you're done with that, you can either toggle that off or toggle back to the file view. And then you can move the terminal. So I usually just sort of clear it off a little bit to the bottom, and then later I go grab it. What else? Oh, if you click the run, then it will run your program, your C++ program. Hey, they're pestering me to upgrade. So right now this program just prints hello world, which is what this code does. Okay, so one warning I will give you if this is the first time you've watched these videos, I am not going to repeat a whole bunch of the outputs. I will talk through them carefully when I do outputs, but one of the big differences you'll notice in C++ is the way that we print to the screen. So I'll talk through them, but they're kind of weird looking. The other thing I've been doing right from the start is this using directive, using namespace standard. And if you put this using namespace std, which means standard at the top, then you can get rid of this standard std : and you'll be glad you did that, because it's going to save you typing std : in a whole bunch of places if you just put this global using namespace std. It's a C++ thing. Okay, so let's do some setup here, because I noticed that this one uses the keyboard input. So if this is your first video, this line up here talks about cnreader.h and cnreader.cpp. This is code that I have written to make keyboard input handling a little easier to do. Keyboard input handling is pretty straightforward in Go, but in C++ it's not. So I've written some code to help with that, and we need to get these incorporated into our REPL project. So the way I do it, first I'll go to the REPL, and I'm going to use the add file icon up here. And I'm going to add a file called cnreader.h. The way this is spelled is very, very important. Don't change the spelling. Spell it exactly like this: capital C-I-N, capital R-E-A-D-E-R.h. And then you either click on it or hit enter, and it creates a new empty file. cnreader.h, it has to be that or it will not work. So now we're going to go back to the project and actually get the stuff that goes in here. So notice our files list now has a new file in it. Now we go back to the project tab. I'm going to click on this just to load the file, and then Control A to select all, Control C to copy, and then back to my REPL, Control V in my cnreader.h. It's about 244 lines, and I'm going to scroll up just so you can see and compare, make sure yours is the same. So I have copied the cnreader.h from the lab that was linked to the lab into my REPL project. If cnreader.h is correct, you should see this copyright statement at the top and then some licensing statements. And again, make sure that the spelling is dead on correct. Capital C-I-N, capital R-E-A-D-E-R.h. CN, by the way, is the C++ term for the keyboard, basically. I don't know why they chose that, but that's what it is. So that's a reference to code that I've written is referencing reading keyboard input. Okay, so there's the first one. There's a second one, so I'm going to add another file. So I'm going to go back here, add file. This one is cnreader.cpp. Same thing, be very, very careful of the spelling or it won't work. Capital C-I-N, capital R-E-A-D-E-R .cpp this time. Hit enter, and it creates a new empty file for you. And then I'm going to go back to the lab page, go to the cnreader.cpp link. It's different inside, so Control A to select all, Control C to copy, and then I go back to my REPL project, and I click in here inside of my cnreader.cpp file to get the cursor, and then Control V to paste all that stuff. This one's longer, this one's 406 lines. And then I'll scroll up to the top so you can see what's at the top is this stuff. So it's different. And I'll show you how to use it, but mostly the setup is just get those two files added to your project. So now the files list of my project is main.cpp. Here's where I left it. cnreader.cpp, that's the one I just pasted into, and cnreader.h, which we pasted into a second ago. With that, we have everything we need to start doing this project. I can make that bigger. Okay, so that's the setup. So we've gotten this far basically, is we've created a project, we've added those two files to it, so now we have 3 files in our project. Now we can start writing some code. Oh, we're gonna have a random number. That's kind of fun. So you need to include ctime for random number generation. So I'm going to go over here to my main.cpp is where I'm working. I'm going to add an include ctime. This is very similar, by the way. If you may or may not remember, but when we've done random numbers in the Go language, we've also had to use time. And this is very similar. While we're up here, let's go ahead and add an include for the cnreader code. And you only include cnreader.h for this. So, and notice also that cnreader.h has quotes as opposed to greater than, less than bracketing. In C++, when you are connecting yourself to some code you've created in local files, like files in the same folder, then you use quotes. So, and you only have to include the .h part. The other part kind of takes care of itself for you. Not really, but it'll look like it. Okay, so there's the include for ctime. That's there because this project has random numbers in it. And mostly, though, I just took that off of reading the lab. But that's what that looks like when it says include ctime. It has the greater than, less than brackets on it. When you see the greater than, less than brackets, that means that that code is included with the C++ installation. When you see quotes around it, it means that that's some custom code that's being connected. And in this case, this cnreader.h custom code is stuff that I wrote to make our lives easier. Okay, that's that first part. Alright, we'll be neat and consistent. Alright, declares one class named looper. So class named looper. And if you remember, a class in C++ is the closest thing in Go is a struct. So this is going to be somewhat like a struct. It's just the organization of it where you put things is slightly different. called looper, and then it's very, very important that that semicolon go there. If you leave that semicolon off, you will get errors. Um, and it's a bummer about C++. It has lots of extra symbols like semicolons that you just sort of have to learn by practice and trial and error when you need them. Eventually, you just learn to recognize where they go, or you make the same mistake enough times that you remember where they have to be. So you have to have one here. You don't want one after this int main section. Okay, so there's the class looper. Now let's start putting stuff in it. So I see that it has 3 functions and no properties. So that's interesting that it has no properties. Usually in the last few labs we've created a private section and then in there we put properties, but looper doesn't have any properties. So I'm actually just going to put a private section and then leave it empty of stuff, and then the public section will have the functions in it. So what I'm about to put in this public, the similar thing is a method in the Go language, and methods in Go are functions that are attached to structs. So C++ doesn't use the term, but what we're going to have here in this public section is methods, functions attached to this looper thing. Alright, let's work on the first one. So there's a function fizzbuzz, uses a for loop that prints integers from 1 to 100, and then does the fizzbuzz problem. Okay, so this is what this would look like in the Go language. It takes no parameters and it returns no data. So that's what it would look like in the Go language. In C++, you put what it returns first, and if it doesn't return anything, you put void. So C++ doesn't have a word like func, F-U-N-C, in it. The first thing that happens when you make a function is you say, what does it return, or does it return nothing? In this case, void means that fizzbuzz returns nothing, and it takes no parameters. So at this point, you're probably starting to recognize this because we've done it a few times. Okay, so we're supposed to use a for loop and go from 1 to 100. So the parentheses you're not used to, but most of the rest of it will look fairly familiar. We're going to say int I equals 0. I is less than or equal to 100, I plus plus. So this is very similar to the way we'd set up a counting loop. I'll do right above and then I'll delete it, but in Go we'd say for int I, we usually use a little bit extra spacing. Right, there's what we do in Go. So very, very similar, right? Go has this ability to figure out what kind of variable I is based on the data you attach to it, whereas in C++ you always have to tell it what kind of data it is. So I is an integer, and its start value is 0. The logic is the same. So I less than or equal. You could put spaces if you want, by the way. I was just being sloppy or lazy about it. C++ doesn't really care much about that. And then count up by 1. So the main difference here is the counting loop has the extra parentheses around the setup. Alright, so you may not remember it, but basically if, so we're going to use a series of if, else if, and then there will be an else part here. And we're just going to fill in what goes in the parentheses. Now I wrote it this way because I wanted you to notice that in C++ we have parentheses around these comparisons. in C++. In the Go language, we don't have these parentheses, but otherwise it looks almost exactly the same. So, oh, someone didn't catch me. I should have started this at 1. I'm going to stop for a second. Everybody make sure you start at 1, not from 0 to 100, but 1 to 100. 1 to 100. Alright, so hopefully everyone got that. Int I equals 1, not 0, because we're supposed to start at 1, go up to and including 100. Okay, so these parentheses are different, but otherwise it's going to look very similar. So we check to see if I mod 15 is 0, which is sort of the quick way of checking to see if any value between 1 and 100 is evenly divisible by 5 and 3, which is the same thing as saying they're evenly divisible by 15. And if you remember our FizzBuzz problem from earlier in the semester, you have to do this one first or it doesn't work. So do an output, cout, FizzBuzz, and a line break. So remember, every time you switch to a different kind of output, you repeat the operator. We call it the insertion operator. So cout is the console, print to screen. So I'm going to print this FizzBuzz string, and then I'm going to switch, and I'm going to spit out the line break marker, ENDL, line break. So we check for evenly divisible by 5 and 3 first. Then we check to see, doesn't really matter after this, but let's say 3. Evenly divisible by 3, then we spit out fizz. Evenly divisible by 5. We spit out buzz. And the else part is anything else in the FizzBuzz problem is we simply spit out the number, the counter. So for the most part that looks, other than the outputs, I know the outputs do look a lot different, but the rest of it, there's some extra symbols in there like parentheses and stuff, extra characters, but it's pretty much the same, right? The mod operator works the same. The comparison for equality looks the same. The if statements look the same except for the extra parentheses. So a lot of that's very, very similar. So here's this whole thing is my FizzBuzz. And then this whole thing is the for loop inside of it. And then this whole thing is what the for loop keeps repeating. And then I left the private section blank because there are no properties as far as we can tell. So let's do what we did with the, I don't remember if we did it with this. We did it with the calculator. Let's just sort of test little pieces as we go. So I'm going to go back to, so we did this first part right here, the FizzBuzz problem. Now I'm going to scroll to the bottom. I don't know that we need a random number yet, but let's fill in enough of this. Let's see, do we need number, quit, FizzBuzz? Okay, we could do it. We could do, I think, all of the stuff from 1 through 6. We want to get down to number 6 so we can see if FizzBuzz works. Oh, look, it was supposed to capitalize the B. Well, I'm not doing that. Okay, so let's do these things in main. So we're going to go down to main and put in a couple of pieces until we get up to testing our FizzBuzz. Alright, so I'm just going to type this part. Don't need hello world. Okay, so this thing. This is seeding the random number generator. So S in front of ran means seed the random number generator. You've done this code in Go. It doesn't look exactly like this, but it's the exact same sort of setup. You have a seeding step that you do first to generate random numbers in C++, just like you do in Go. So that's part one of main, srand, and then time 0. Doesn't actually mean time 0. That 0 is actually just sort of creating a blank spot. It's not anything to worry about. But it's basically the exact same mechanisms at play as when we do random numbers in the Go language. What was step 2? Create a CN reader called reader. Okay. We've done this before as well. So this CN reader contains the code that makes reading keyboard input easier. And then this reader is an instance. It's going to be the way that we access the code that does the keyboard input handling. Alright, that's step 2 for main. Step 3 for main is create a looper. So create a looper called looper1. So looper is the new code that we are introducing here. Let's see if I can get it all on the screen. So here's my class looper up here. So this looper, that's how we're going to access the code that's inside of here, and then more specifically we need an instance of it to actually fire off our FizzBuzz function, looper1. There's some other stuff in between, so let's just keep doing it until we get to what we want. Declare a variable named number that's an integer, can do. And remember, in C++, the data type comes first, and you don't get 0 for free. So data type, variable name, and then you need to give it a start value because C++ won't give it one for you. It literally just has some garbage value in it. It's random garbage value, and we want it to be 0, predictable. But that 0 part, Go does that for you. Okay, number 5, quit, which is a character. Char quit. Okay, so I usually do this for characters. Now, we haven't done individual characters in Go this semester, so you haven't seen anything. And in fact, Go actually doesn't have anything called char, character. It has something called rune, which is sort of similar. But in C++, we have a data type for individual single characters called char. So quit is a single character holding variable. And in C++, when you want to represent a single character, you use single quotes. So single quotes, single character. Double quotes is a string. Now, I personally put a Z in there, just kind of meaning 0. That doesn't actually do anything. You should be in the habit in C++ of giving everybody a start value. So I use Z. Some people use X. Some people use O. You could literally use the character 0 if you wanted, but for some reason I like Z. I guess because reading it as 0 is why I like it. Okay, so that's step 5 in the lab. And then step 6 is invoking FizzBuzz with my looper1. So just please note here, the function as we named it, in the lab it refers to FizzBuzz with a capital, but should we change that? Probably we should. Probably we should. I don't like it, but I'm doing it. So in the lab, it wanted me to call the function FizzBuzz with a capital B. If I change the function name inside a looper, then I have to change the function name when I invoke it in main. So please double check that. Inside my class looper, I changed FizzBuzz to have a capital B, camel casing. And then inside of main, I had to change it as well. So looper1 dot fizzbuzz with a capital B to match. But with that step, we're far enough where we can click run, and let's see if the fizzbuzz program works. So I'm going to stretch my screen up, and I'm going to click run, and hopefully I don't have any errors, and then see fizzbuzz. 1 through 100, it's going to be a lot. I'm going to scroll the terminal screen up. So 1, 2, 3 is fizz, 5 buzz, 6 is fizz, and then I'm just going to start looking for the 15s. So 15 is fizz buzz, 30 is fizz buzz, 45 is fizz buzz, 60 is fizz buzz, 75 is fizz buzz, 90 is fizz buzz, and that's the last one. So this is just a quick error check. So that's the fizzbuzz program running, or the fizzbuzz function doing its thing. The last value is a buzz, which is correct. 100 is divisible by 5. 99 is divisible by 3, and 98 is divisible by neither of them. So that makes sense. Okay, so we'll just do a... I'm just going to wait for a second and make sure everyone has got something that's cooperating with you. So if you are getting an error somewhere, please let me know. And if you're not working in Replit, don't forget that you have to compile both cnreader.cpp and main.cpp. Alright, so baby doll's all good. Hopefully everyone else. Alright, Tyler's good. And mostly, if, I just usually wait for maybe 2 or 3 people to say they're okay, but this is a chance if something's not working, don't be shy. There's a lot of symbols that we're typing, right? There's a lot of weird looking characters in here, so it's very easy to have your fingers slip. Okay. So let's go back to the lab. So if you notice, the pattern's going to be we're going to come up here and we're going to do something new for the looper class, and then we're going to go down to main and write code until we get to trying out that new thing that we did. Okay, so the new function countdown. This one's a little bit different because it accepts a parameter that's an integer named countdown1. Uses a while loop to display the values from the start to 0. Although this one it says 5, 4, 3, 2, 1, lift off, assuming that 5 was the countdown value. Yeah, followed by lift off. So, not actually to 0, I don't think. But I get it. We count down from something, and then the last actual number we show is 1, and then we spit out lift off. Okay. And it's really just a number and a space, and a number and a space, and a number and a space, and then the last one, and then lift off. Okay. Let's try that out. What's it called? Count down with a big D. Okay, so I'm going to go back to my class looper here. Back to the public section, just like we've been doing on the last few. And I'm going to go down a couple lines, and I'm going to make a new function, count down. This one's different because it takes a parameter. And remember that in C++, the data type comes first. So it's an integer, and we're going to call it count down from. It doesn't return anything, so in C++, we put a void here. I'm pleased with that we picked this one because we're getting to see some loops and some ifs and stuff, so you get to see a little bit more of how C++ does these things. Okay, so coming from the Go language, you're going to see a kind of loop that we've never done before. Now, what does it want me to do? Uses a while loop to the... Okay, so while loop. Let me write this in Go first. So what we would say here is for count down. And then you can just sort of watch this part. So in the Go language, every loop, every repetition construct is a for loop. Every loop is a for loop in Go. But in C++, they actually use different loops for different setups. I much prefer Go. It just uses the same loop with a different setup. But in C++, if you want a different setup, you use a different loop. So this is how we'd write this loop in the Go language. And we would print out the countdown variable. Right, I'll just finish the thought. So we'd print out the countdown variable, and then we decrement the countdown variable. So this is how we'd write this in the Go language. And then at the end we'd say like that. Is how we do it in Go. So in C++, maybe I'll just go for a line-to-line translation. So in C++, we'd use a while loop for this. It would have been, I think the Go language designers were clever to realize that we don't need different words for different looping setups. I think that was very clever, but in C++, unfortunately, there's a different loop for this setup. So while the countdown from variable is greater than 0, let's port this to C++. So we'll cout, print out the countdown from variable with a space after it. The only thing wrong with the minus minus line is that in C++ it needs a semicolon at the end. And then this output really just changes from the fumped style to the cout style. Now this \n, that's a line break. If you want to, you can get the exact same effect, and some people just prefer to do it this way. So instead of putting a \n in here, I can use an N to L. I usually pick that based on which I think is going to type faster for me, or what I think looks nicer. So to me, I think this actually looks a little nicer that way. So I'm going to use the ENDL way of doing a line break as opposed to putting a \n in here. So not that, this instead. Even though technically that does require more typing. But I think it looks nice that way. All right, so there's the countdown loop. It's going to count down from something to 0, printing out each number in the countdown with a space after it until it hits 0, at which point it'll say ... lift off. Hey, which is appropriate. I don't know if you guys are into that, but the SpaceX launch of 2 American astronauts from Cape Canaveral in Florida didn't go off yesterday, so they're rescheduled for Saturday, if you're into this kind of thing. SpaceX, by the way, they recruit and hire C++ programmers a fair amount. Something to think about. I've been attracted by their sales pitch before. I didn't go, obviously, but I thought it sounded exciting. Okay, so there's my countdown function. It is part of the looper class. So I think it's done. So now I'm going to scroll down to my main, and I'm going to add in uh, more code. So I went through part 6. Now I need to start part 7. So in a do while loop, ends its loop, enters y or y. Okay, so this is the other kind of loop. So in C++, there's 3 types of loops. In the Go language, there's 1 type of loop with different setups. In C++, there's 3 types of loops with 3 setups. So the loop it's asking me to write looks funky. It looks like this. It's called a do while loop. There's no reason why this should exist in the universe, but it does. You totally don't need this, but since it's a part of C++, I usually show it to people. Some people like it, some people don't. You can write every piece of software you will ever write in the world without it. But anyway, here it is. The semicolon is important. One of the reasons I hate the do while loop in C++ is because of that semicolon, because if you leave it off, you get an error. And then the condition. So in the parentheses, so this is a repeat until is how some people might describe it. Keep repeating some things until some condition is met. So it's the condition that we need. And I know because I wrote the lab and I just reminded myself, I remembered what it's about. The condition we're looking for, or how should we say that? While, so we have this char variable called quit. Oh, it's a z right now, right? Well, that's fine. Let me go back a step. I think you might understand better what's about to happen if we go back a step. So we're going to come back to this condition in a little bit. So this is a loop that's causing something to repeat. Inside of this loop is going to be a question. It is right here. Ask the user if they want to quit, and then decide whether or not to continue, whether or not, based on how they answer. So let's do that in the loop. So do you want to quit? And then I'm going to use my quit variable to capture that single y or n that they type. So reader.read quit is a char. And then I'll just show you one of these sort of extra goodies that you get with the code that I wrote for this reader stuff. Alright, so do you want to quit? Yes or no? So I'm going to use my quit char variable to capture the char that we read from the keyboard. But you can actually, in my code, you can say what the allowable characters are. So inside of double quotes, you can actually list out all of the characters that you will allow them to type. And if they don't type one of those, my code actually will emit an error. Okay, so we have a prompt here to them. Do you want to quit? Yes or no? Then we use our quit variable that we declared up here to capture what we read from the keyboard, and then we use the grouping and double quotes to trigger an error. That's the way the code that I wrote works. You actually have the ability to tell it which characters are allowable. Big Y, little y, big N, little n are allowed, and nothing else. If you type anything else, my CN reader code will actually spit out an error. We'll try it here in a second. Okay, but the reason we did this first is because what they type here decides whether or not we continue. So let's think about what quit would be that would make me want to quit. I can either quit on a Y or an N. I'm going to say if they type an N, then they want to keep going. Now since I'm allowing a big N, I'm going to say or. So if they typed a little n or if they typed in a big N, that means no, they don't want to quit, which means keep going. So as long as they type no, big N, or little n in answer to that question, we're going to keep going. Hopefully that makes sense. This is the same logical OR that we use in the Go language. So as long as that quit variable has a little n or it has a big N, we're going to keep going. But I went back and I did these 2 steps because I thought it would probably help explain what is going on right here. While they're typing no's, I don't want to quit, we're going to keep repeating. Okay, I'm going to push those. So I added an extra blank line at the top of this loop because I'm going to put some stuff in here, I think. Hopefully I'm not going too fast. I'll pause after I finish this next thought. So what do we want to do? Yeah, we're going to ask them for a number between 1 and 20 and then do a countdown on that number. Okay, so at the top of the loop, does it tell me how to ask that question? No. It just says to ask them for a number between 1 and 20. So notice where I am inside of my while loop here, where we're working. So the first thing that the loop does is it asks them this question. Please enter a number between 1 and 20. I have a number variable. So I'm going to use that number variable to capture what I read from the keyboard. Number is an integer, so what I want to read is an integer. And then there's another trick that we can use here. So in my code, in my CN Reader code, I made it so that you can say what the allowable range of integer inputs is. It's slightly different from the way rechar works, where I said what chars will I accept. This one is what range will I accept. Anything from 1 up to 20. Inclusive, meaning 1 and 20 are also allowed. So if the user should type in something that's not between 1 and 20, they get an error. And we'll try it just to prove that that's working. And then what we're supposed to do with that number is we're supposed to have looper 1 do a countdown with it. And then I'm going to hit pause and give everyone a chance to catch up a little bit. So this one is a little bit more elaborate, and we're actually using some of the extra features of my CN Reader code. So these are things that, of course, we didn't have in the Go language. I have written a similar library, we just didn't use it this semester in Go. In C++, though, it seems it makes life a lot better. So it turns out that if you put numbers in there, it will limit my code will limit their input to between 1 and 20. Okay, so I'm going to run it, make sure it works, and then I'm going to put my code back on the screen, and I'm going to go refill my water real quick. So it's still going to do fizzbuzz. Fizzbuzz is not repeated because that happens before the do while loop. So here's the number between 1 and 20. I'm going to put 21 just to be a jerk. So do you see that error right there and the re-enter prompt? That's my code actually doing that. So because we put reader.readInt 1, 20, that allows my code to detect and then triggers this error message. If you put a 0 in here, you'll get an error also, or a -1. So you have to put between 1 and 20, or my code won't accept it. So I'm going to put a 10. There's the countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off. And then do you want to quit? So there's the next part in theory, if I put anything that's not a big Y, big N, little n, I'll get an error. So I'm going to try a G. So that error right there, that's my code. Again, that's the CN reader code trapping that error. And it's just going to keep going. So I put in a minus, that don't work. So do I want to quit? Yes, I do. Which should quit, I hope. Alright, so there it quit. So I'm going to put my code back on the screen. I'm going to go fetch some water before I do that last function. Let's see how much of it I can get on there for you. Yeah, I can get all of the countdown function and all of main. So give me a sec and then I'll check in with you and see if you're doing okay. Okay, so um, I think sometimes I probably lose a sense of how fast or slow I'm going. Hopefully not too fast for that section. We haven't even used the random number part yet, so hopefully that comes up next. So hopefully you guys are doing all right. Okay, so Tyler's all good. I get just a status check from anybody else, either thumbs up or thumbs down if you need a pause. All right, baby doll's all good as well. Okay, so the last bit so now we go up, find the target number. Accepts a parameter, declares some variables, uses a do while loop. Ooh. Very interesting. Okay, this one is going to be fun. Alright, so function find the target number that accepts as a parameter target number. I'm going to have to come back and forth a little bit, so let's just get the function set up first. So we're going to go back up to our looper class. And in the public section, we're just going to go down and we're going to set up for find the target number. This one won't return anything either. I forget what I'm supposed to call the parameter target number, which is an integer. So it accepts a parameter target number. So what it's going to make the computer do? We're going to give the computer a target number, and it's going to generate random numbers. And it's going to keep generating random numbers until it gets the target number. And it's just sort of a little experiment. Like, how long does it take with the computer generating random numbers to actually get to the number that I told it? So it's like the computer wildly guessing at my number with no logic to direct it higher or lower. It's just wildly guessing over and over and over again. Okay, so I think I saw it uses, all right, declares two variables, passes and random number. Okay, so we're going to have two variables inside the function just for the purposes, just for use by the function. So remember, integer variables, need to be, in fact, all variables in C++ just come up with some sort of zero-like value. Passes, and also I have a variable for random number. And because C++ does not zero them out for you, it's good practice to zero them out for yourself. This passes. We're going to, every time the computer makes a guess to try to find the target number randomly, we're going to count that as a pass. So at the end, we will be able to display how many random guesses did it take the computer to find the target number. Okay, so those are the two. Uses a do-while loop. Continues, so I'm kind of reading all four of these at once. Uses a do-while loop, increments passes on each pass through the loop, assigns a, well, let's set up the do-while loop. That's getting to be too much for me to read. Remember, do-while loops are just nasty. So there's the basic setup of a do-while loop. The semicolon has to be there or you will get an error. And then we'll figure out what goes in the parentheses as we read our way down the instruction. So the first thing that it says happens, so there's the do-while loop. The first thing that the loop does is it increments passes. Okay, so passes plus plus. You can also do passes plus equals 1 or passes equals passes plus 1. C++ is happy with any of those approaches, and they're all equally good. So whichever one you prefer, use that one. I like the plus plus style, but all of those are the same. So there's passes plus plus. So this is just counting how many times this repetition happens. Passes plus plus. Assigns a randomly generated number between 1 and 1,000. Okay. So random number equals. So every time we repeat this loop, we're going to get a new random number. And in C++, you do that with the rand function. Pretty similar to Go. Now in this case, Go has a nice function where you can plug in how big you want the random number to be, but in C++ you have to do that for yourself. So if we do mod 1,000, we're going to get numbers in the range anywhere from 0 to 999. If we want that range to actually be 1 to 1,000, we just add 1. So there's the magic of taking any random number, any positive integer, from 1 to a gajillion jillion, mod 1,000 has to yield something from 0 to 999. And if you take 0 to 999 and you add 1 to it, you get 1 to 1,000. So this math right here with the random number is how I guarantee that that random number is between 1 and 1,000. And then what happens next? So this whole 1,000 plus 1 part, the Go language actually has that built in. It does that for you. And then continues until the random number matches the target. Okay, so that's the while loop condition, is while the random number is not equal to the target number, it's going to guess again. So we want to keep doing passes and making random guesses by the computer as long as the random number that the computer is guessing is not a match for the target number it's been given. So it's kind of sad that we're making the computer do that. Guess at random without giving the computer any help. It just has to guess randomly. Once that while loop is done, that means that the computer managed to successfully find a random number that matches the target. In which case we're supposed to put out a sentence. So I'm going to take this. So we're supposed to print out this message. Now we're going to have to plug the hole or poke holes in it. which is a lot more painful in C++. So right here, we want the variable passes. So what we have to do is we have to close it took space. Then we have to do this operator to get passes in there. And then we have to do that operator again to continue with the rest of it. Now we still have another hole to poke. But you sort of have to just be very careful when you do that. So output it took space, stop. Output passes, stop. And then output the rest of it, stop. And then output the line break. We're going to have to do that again right here. I'm going to go down. And what we want here is the target number. Okay, so just study this a little bit. So output to the console, first is this part, it took space. Then the passes variable, that counter that kept track of how many wild guesses it had to make to get there. Then the piece of the sentence after passes, space passes to randomly generate the value, space, stop. And then I took it to the next line down so it'd be easier to read. So now output the target number. And then switch to outputting the period. And then switch to outputting the line break. I think I'm going to flick over real quick. Okay, that's all that function is supposed to do. So here's that whole function. So it's the computer randomly guessing until it matches some target number. And it just has to randomly guess. It doesn't. It's not being told if it was too high or too low or anything. It just has to keep randomly guessing until it randomly guesses a match for the target number. Okay. So hopefully that's okay. It's very impressive that you're keeping up with me roughly at speed and also with the mess that C++ is. Maybe by now, though, probably you guys who have been doing it for several get-togethers now, you're probably starting to feel familiar. Okay, so the last step is going to be what main has to do to make that stuff work. I'm going to have to, I'm pretty positive that's going to go, so down in main. Pretty positive that after the looper does the countdown and before we do the do you want to quit, we're going to insert some stuff right there. Alright, what is the stuff? Ask them for a number between 1 and 1,000. Use the CN reader code to guarantee that you only get between 1 and 1,000, and then fire off that function that we just wrote. Alright, so that's fairly straightforward. See out, enter a number between 1 and 1,000 this time. I'm going to reuse the number variable for this section. Read int, because number is still an integer, but I'm going to reuse it for this part. We want to allow everything from 1 to 1,000 this time. And then looper 1 dot, I'm going to use this little pop-up feature, find the target number, and the target number is that number that I just read from the keyboard. So it's a little bit of a toy, this find the target number, but when I created this lab, I wanted people to see like all the different loops, and I wanted them to see how do you do random numbers, and there's a little bit of the sort of the basic arithmetic in here. Plus, for some reason, I'm sort of fascinated by making the computer do work for me and um, keeping track of how long it takes to figure out how to satisfy my needs. I'm getting a reload here. Hold on. Hopefully it didn't lose anything. Probably not. Anyway, I'm going to go try it. So I know it's going to run the FizzBuzz once, but that's not repeated. Hello? Alright, here it goes. For some reason it took a while that time. Okay, so enter a number between 1 and 20. I'll just do 5 this time. There's the countdown. Okay, so now here's the enter a number between 1 and 1,000. Let's just say 500. So it's going to make the computer guess random numbers until it finds a match, and it will tell me how many random guesses it took for the computer to do that. So 762 passes, which I don't want to quit this time. So there's the countdown thingy. I'm just going to do 1 this time. And I'm going to go, let's just see how long it takes to generate 1. 635 passes. That's totally random. I don't want to quit. 1. 42, just for no good reason. For some reason, that one took it 3,281 passes to find a match. I want to quit, yes. Okay, so that's that program. Hopefully it showed you some stuff about C++, the tools that you have available, and kind of gave you more practice and just feeling familiar with the way the code looks and feels. Is that the whole lab? I think that's the whole lab. Yeah, that's the whole lab. So I'm happy to answer questions, get your stuff working. Scroll my code around if you need to go back and look at something here. Any of those things. I'm going to restore my Atom editor. Okay, you can still see. So if you weren't here at the beginning, or you haven't heard this before, but just as a reminder, what you're seeing on the screen is the 5 C++ labs that I have done walkthroughs for. So you can use any 2 of those 5 to satisfy the final lab for CSCI 20. Any 2 of those. The dates there are there so that you can go find the videos if you want to see the walkthroughs. So those are the dates when the videos were made, doing walkthroughs on those different labs. So any 2 of those. Today we did what I would call the FizzBuzz lab. And this is the last one. So Raspberry Pi. What's the current one? Oh, Nate, let me go grab a let me go get I'll get an Amazon link and I'll plug it in here. What are we on? Model B? What's the current? Yeah, so I mean, I think that you can just get does this one come with, it may not, capacity 4 gigs. Well, so here's a basic one. Hopefully this comes through as a link. So that's just the board itself. And then if you scroll down, it'll tell you that you should probably get it has an HDMI cable. I don't think you need that. You do need, don't you need a card for the operating system, or has it changed how that works now? Well, I guess it's, oh, it's got 4 gigs on it. Is that the, or is that USB ports? Oh, I guess it has the memory on board already, so you don't even have to buy a memory card anymore. You just need a USB cable to power it, I think. But oh, with all the goodies attached? Yeah, if you want to do lots of experiments, then does this come with the board? Okay, so you still want to buy the board separately, right? So make sure that you still get. So these are just parts that you can do experiments with. Does it come with tutorials and stuff? It does. Oh, I like that. So you'd want to get that and a board. Let's see what this CanaKit starter does. So if you go on that same, hopefully I left it where you can see what I'm looking at. Yeah. Let me hide Adam. So if you go down here to this part, the CanaKit board, it's $100. What do you get for $100? You get a micro SD card, that could be handy. You get a case for the Raspberry Pi, that's kind of nice. Ooh, with a fan, that's interesting. You get a HDMI cable. What's this thing? Some kind of switch. USB-C power supply. If the cost doesn't put you off, I would totally get those two things. So this kit does not come with the Raspberry Pi itself. It's just a whole bunch of goodies. Plus, it comes with a it's a link, but there's a 430-page basically ebook with tutorials that probably show you how to connect all these bits and pieces. Stop that. We'll stop it. We'll show you how to connect all these bits and do different things. So I think that would be totally awesome. That one's $50, which is pretty good for all this stuff. Like, so you get an LED screen and you get a keypad, get a whole bunch of buttons and external power. This is probably like a photo receptor or something. There's a motor. Oh, this is totally awesome. And it looks like you can write C, Python, or Java for the tutorials. So yeah, that's pretty neat. Technically, you don't need a whole starter kit. But if the cost doesn't put you off, this does sort of have some desirable goodies in it, like an HDMI cable and a USB-C power supply for it, and a case, which is a nice looking case, by the way, for the board itself, so that the green board goes in that case. If those costs don't put you off, that's pretty sweet. It's $150 for a lot of stuff. So yes. So if you're a mechatronic engineer, absolutely this would be to your benefit to do these experiments. Yeah, no question about it. And I notice in this kit, for example, there's going to be experiments on motor control and programming sensors and doing outputs and stuff. So yeah, no question it would be beneficial to you to do this. Plus, it would just be a lot of fun, I think, to do. So yeah, highly recommended. Potentiometers in there. It's got tons of stuff. Yeah, totally do it. If someone will help fund it, then yeah, I I might do that in the summer just because this looks so awesome. Totally do that if you can afford it. Okay, totally get those two things. You need the kit with the board in it, and then that set of components and with the tutorials. Then I think you're off and running. That's really cool stuff. Okay, anybody else out there got questions for me? Uh, a special thank you to those of you who joined me on the live broadcast on a regular basis or somewhat frequently. I really appreciate it. This has not been easy for me to get through doing teaching like this because I teach. I like to be around people and I like to get a sense of um, how people are reacting to what they're hearing and whether or not they're sort of getting it. And it's very difficult to do online. So I appreciate you being out there with questions and with helping out with the code and like plugging in the functions that you did. I really, really appreciate it. It made a huge difference for me. So thank you for that. And hopefully you're walking away with enough of the experience that you can build on it. It's not exactly as I would have it go, but we did our best, I think. Um, Thank you, Nate. I very much appreciate it. Okay, so everybody be good. I'm basically only available for one more day before summer starts. I still have to sit down and do some grading, of course, but for the most part, I go dark until the fall. I do monitor my emails a little bit, so if you have any lingering questions, feel free to ask. Um, yeah, thank you, baby doll. Appreciate it. And I think your semester did go well. I mean, from where I sat, your semester went excellently, so that's great. Um, Thank you. I appreciate it. Good luck to everybody. If you're still at Butte College in the fall and you're taking P&A 2, then you may or may not have seen it yet, but you're getting me, so I'm sorry about that. Um, I'm not going to broadcast every class the whole semester in the fall, but um, I'll still be online quite a bit. So again, if you have questions, don't hesitate to email. If it's about doing summer projects, I correspond with a lot of current and former students over the summer when they're gearing up to um, find projects or things to practice on. That Raspberry Pi stuff that Nate was showing us is really awesome way to practice your programming. And if you're in one of the engineering fields, um, uh, definitely something that you should consider. It's not the cheapest thing in the world, but you sure do get a lot of goodies with those two kits. Uh, Okay, so everybody take care. Hopefully things go well for you, and if you have any questions for me, um, don't hesitate to email.